All right, guys, welcome back. Now we're going to talk about word problems using direct variation. So we are given the distance required to stop a car is directly proportional to the speed. If 350 feet is required to stop a car traveling 70 miles per hour, how many feet is required to stop a car traveling 90 miles per hour? So now let's go back and read it again, underlining keywords. The distance required to stop a car is directly proportional to the speed. So distance required to stop a car, what I'm going to put is D as my variable. Okay? Is directly proportional. We know is directly proportional to means equals K times the speed. So for the speed, I'm going to put S. If 350 feet, so 350 feet is required to stop a car traveling 70 miles per hour. So we know 70. What does 350 stand for? Feet is required to stop. So required to stop, we know required to stop is, for my D value, car traveling 70 miles per hour. And we know miles per hour is the speed. So that's my S value. How many feet is required to stop a car traveling 90 miles per hour? 90 miles per hour, remember, this is going to be my speed. Feet is required to stop. Required to stop. We're looking for our D value. So what we're going to do is, first thing is set up the equation. We know D is equal to K times S. Now, if 300 feet is required to stop, 300 feet is my D value, equals K times S. S is going to be miles per hour, so that's 70. Now what I need to do is get K by itself. Well, in order to do that, I know this is multiplication, so what I'm going to do is divide. I'm going to divide both sides by 70. 350 divided by 70 is 5, is equal to K. So I know my K value is 5. Now let me go ahead and write the equation again. D is equal to K times S. So I know K is equal to 5. And I know my S is equal to 90. So times 90. Now I'm looking for D. 5 times 90 is 450 equals my D. So the distance required to stop a car is 450 feet. If you have any questions, please let me know.